So when we're doing algebra, a letter that represents one or more numbers is known as a variable, right? So variables can be things like x, y, z, a, b, c. Those are all variables. They represent a number. Now, sometimes we'll have expressions like 2a minus b plus 4 or 5 divided by x plus 3. These are called algebraic expressions, and some algebraic expressions are called polynomials. And so there's different types of polynomials. First, we have a monomial. A monomial is a number variable or the product of numbers of variables. So you multiply, divide them, you get a monomial. But when we have a monomial, the exponent has to be a positive integer in the numerator. Numbers that multiply the variables are called numerical coefficients. So for example, 6x, the numerical coefficient is 6, and the variable would be x here. So these are examples of monomials where you have one terms, and with all of these you don't have a separation with addition or subtraction. Now when we have a polynomial, this is a monomial or a sum or difference of monomials. So a polynomial, 6, even though it's a monomial, it's also a polynomial. But when you have more than one monomial together, so 2y and 7z by themselves would be polynomials or monomials, but together they form a polynomial. Now, example number 1. Explain why 5 divided by x plus 3 is not a polynomial. Well, one of the criteria for polynomials is that it has to have a positive integer in the numerator. Now, this 5 divided by x, we could express this as 5 divided by x to the power of 1 plus 3. And if I were to rewrite this, this is the same thing as saying 5 to the x negative 1 plus 3. And because this is not, my exponent is not a positive integer, it is not a polynomial. So the exponent is not a positive integer. Now, there's different ways to classify polynomials. First of all, there's two ways. We can identify a polynomial by the number of terms it has, and also by the degree of the polynomial. And I'll show you what I mean by this. So first of all, number of terms, and secondly, the degree of the polynomial. So first of all, a polynomial may be classified by the number of terms it contains. Now, a term number can be a number, it can be a variable, or it can be the product of the numbers and variables. If there's more than one term, then the terms are going to be connected by addition or subtraction signs. So a polynomial, which is one term, is known as a monomial. Mono meaning one, and an example of that would be 4x. However, if there's two terms, we would call it a binomial. So x plus 4. A trinomial would have three terms, x squared plus x plus 4. So see how they're being separated by addition or subtraction signs. A polynomial with 4 or more terms is simply called a polynomial when classifying the number of terms. So if we had something that was like, let's say x cubed minus x squared plus x minus 7, even though there's 4 terms, we wouldn't call it a tetranomial or anything like that. This is just a polynomial. We would just identify this as a polynomial. Now consider the following expressions, algebraic expressions. In each case, state whether the expression represents a polynomial or not. If the expression does not represent a polynomial, explain why. If the expression does represent a polynomial, state whether the polynomial is a monomial, binomial, or trinomial. All right. A, this is a polynomial, and this happens to be a binomial. So we have positive integers. The exponents on our variables are positives, and yeah, so we're good. Two terms because we have two numbers being separated by a subtraction sign. This one, is not a polynomial. This next one is not a polynomial. The exponent is not a positive integer. So even though it is a positive number, that's not an integer. Let's see. Root 7 x to the power of 4 minus x cubed plus 1. This is a polynomial. And this is also, it has 3 terms, so that's a trinomial. 3x squared plus 9x minus 4x squared is not a polynomial. And for the same reason that b was not a polynomial, actually, the exponent 0.2, yeah, right there, same thing as 1/5, is not a positive integer. And last one, also not a polynomial for the same reason. This a, so 7 over a, is the same thing as saying 7a to the negative 1. All right, next we're looking at example number 3. In example number 3, it's very similar to the above example, although in a table format. And so these are all polynomials. We're told they're polynomials. All we got to do is identify the number of variables, the number of terms, and the classification by the number of terms. So first of all, I have 1, 2, 3 variable, x, y, z. So x, y, z are my variables. So there are 3 of them. Number of terms are 2. I have 4x and I have 3yz. That's 2 terms. If there's 2 terms, that means we have a binomial. Next, we have 2a minus 4b plus c. A, B, C, I have 3 variables, 1, 2, 3, and I also happen to have 3 terms because I have 2a, 4b, and 7c, and being separated by my subtraction and addition sign. So 3 terms. 3 terms means it is a trinomial. Tri meaning 3. X squared plus 3x plus 4. We have 1 variable, just x here and an x here, but I have 3 terms, and this is also a trinomial. Root 2x, there's only 1 variable, and there is 1 term, which means this is a monomial. And lastly, I have x, and x, a y, and a y. So there's 2 different types of variables. However, there are 1, 2, 3, 4 different terms. We would express this as a polynomial. So polynomial.